Hi guys, today we're going to be going over converting from a complex rectangular point to a complex polar point. Okay, so something that you must always keep track of is where your point lives. You want to know where your quadrant, or what point your quadrant, or what quadrant your point lies in. Okay, so if you recall, okay, the first quadrant has coordinates of positive, positive. Second quadrant has coordinates that are negative, positive. The third quadrant has coordinates that are negative, negative. And then the fourth quadrant in the rectangular coordinate system is positive, negative. Okay, so we're going to convert the rectangular complex number 5 radical 2 over 2 minus 5 radical 2 over 2i. Okay, if I were going to graph this, the first or the real part of the complex number is positive, and the imaginary part of the number is negative. So that would put my point somewhere in quadrant 4. Now, I need to make sure when I find my polar form of my complex number that the angle that I'm going to use lives in quadrant 4. Okay? So, to review, the polar form of a complex number is this: r, quantity cosine of theta, plus I sine theta. So you need to find two things. You need to find r, which is the radius, and theta, which is the angle. Okay, now radius is the same as the modulus. Okay, if you remember the modulus back from our distance section. Okay, modulus is basically the distance between the point and the origin 0, 0. What we're going to do is we're going to use kind of a modified Pythagoras to do that. So we're going to go r is equal to the square root of a squared plus b squared. Okay, now I know that our a and our b have a radical and they're also fractional, but this is not a big deal. Okay, so here we go. Just plugging in the numbers. Okay, remember you've got a big old square root. Okay, so take these in pieces. So what you get is 5 squared, which is 25. Okay, the square root of 2 squared is 2. And then 2 squared is 4. Okay, then same thing over here because you're squaring the exact same number. Okay, and again, remember you have that big old radical. So we have 50 over 4 plus 50 over 4, which is 100 over 4. Don't drop your square root, which is the square root of 25, which is 5. So my r is 5. So I can actually start filling out my complex polar like that. So I have about half of it done. Now, kind of the not so easy part is finding theta. So this particular one is set up so it's going to be on the unit circle. Okay, so this one is actually a little bit easier than the ones you would do with the calculator. All right, so we're going to go ahead and find theta. Okay, to find theta, okay, first thing you need to remember is we already decided we are in quadrant 4. So I am going to look at quadrant 4. Okay, So my angles can be 3 pi over 2, 5 pi over 3, 7 pi over 4, 11 pi over 6, or 2 pi. Okay, so now you've got to remember that your x and y, or a comma b for your point, is the same as cosine theta, sine theta. Okay, so when we look at those points, they're actually equivalent to trig ratios for that angle. Okay, so what we're going to do is we're going to find tangent of theta, which is sine theta over cosine theta. All right, so I'm going to do this for the three angles that I think are possibilities in quadrant 4. So I'm going to look at 5 pi over 3, 7 pi over 4, and 11 pi over 6. Okay, so if I look at 11 pi over 6, I get sine of 1 half over negative radical 3 over 2. If I look at 5 pi over 3, I get negative radical 3 over 2 divided by negative 1 half. And then if I look at 7 pi over 4, I get radical 2 over 2, radical 2 over 2. Okay, so if I simplify all those, I get tangent 11 pi over 6 is equal to 1 over the square root of negative 3. Tangent 5 pi over 3 is equal to negative radical 3. And then tangent of 7 pi over 4 is, whoops, dropped to negative 1. Okay, now I'm going to do the same thing for my rectangular number that we started with. Okay, so that's positive. So if I do the same thing, whoops. Okay. I just realized I put my negative in the wrong spot. Fix that really quick. Okay, all right, so if I simplify that, what do I get? I get negative 1. So what angle should I be using? Well, I should be using 7 pi over 4. Okay, so I kind of have to hunt for it. Now, if you can use the kind of clues, and as you get used to it, this gets a little bit faster. You don't have to show every little single step. So, but from this, I know that my theta is equal to 7 pi over 4. Okay, so now I'm ready to build my number. Okay, so here we go. The polar form of my complex number is 5 quantity sine 7 pi over 4 plus cosine There we go. Okay, now what we're going to do is on the next video we're going to try one without a calculator, or with a calculator, excuse me, because that's going to work a little bit different. But I would highly recommend that you have the unit circle kind of next to you and you try to use it as much as possible. Okay, it does get a little bit faster.